Hello students, today we are going to study Introduction to Runway Design. Now what do you mean by runway orientation? Runway is usually oriented in the direction of prevailing wind, that is, the direction of wind is opposite to the direction of landing and takeoff. The headwind provides greater lift force on the wing of aircraft when it is taking off, so that aircraft rises above the ground much earlier and in a shorter length of runway. During landing, headwind provides braking effect to the aircraft so that it comes to stop in a shorter length of runway. If landing and takeoff operation done along the wind direction would require longer runway. Now the basic runway length. It is length of runway under the following assumed condition at airport. The first one is airport altitude is at sea level. Next one is temperature at airport is standard, that is 15 degrees Celsius. Another one is runway is leveled in longitudinal direction. Next one is no wind blowing on runway. Another one is aircraft is loaded at its full loading capacity. Next one is there is no wind blowing en route to destination, and the last one is en route temperature is standard. Now the next one is correction for elevation, temperature and gradient. The basic runway length is for mean sea level elevation having standard atmospheric condition. Now necessary corrections are to be applied for elevation, temperature and gradient for actual site of construction. Now the first type of correction is correction for elevation. As the elevation increases, air density reduces. Lift reduces on the wing of aircraft and aircraft required greater ground speed. To achieve greater ground speed, longer length of runway required. According to ICAO, BRL, that is basic runway length, should increase at a rate of 7% per 300 meter rise in elevation from MSL. Now the next one is correction for temperature. Airport reference temperature will be equals to TA plus Tm minus TA divided by 3, where TA is the monthly mean of average daily temperature of hottest month and Tm is the monthly mean of maximum daily temperature. As airport reference temperature rise, same effect as the rise in elevation. According to ICAO, basic runway length after have been corrected for elevation should further increase by 1% for 1 degree Celsius rise in airport reference temperature above the standard atmospheric temperature at that elevation. Temperature gradient of standard atmosphere from MSL to altitude where temperature is 15.5 degrees Celsius is negative, that is 0.0065 degrees Celsius per meter. Now temperature gradient becomes 0 above the elevation where temperature is 15.5 degrees Celsius. Now next is the check for total correction for elevation plus temperature. According to ICAO, if combined correction exceeds 35% of basic runway length, then these corrections should be further checked by specific study at the site by model test. Now correction for gradient. In steeper gradient, to attain the desired ground speed, longer length of runway required. ICAO does not recommend any correction for gradient. FAA recommend the correction, that is after corrected temperature and elevation correction, basic runway length should increase by rate of 20% for every 1% in effective gradient. Effective gradient is defined as maximum difference in elevation between highest and lowest point on runway divided by total length of runway. That is all about the introduction to runway design. Thank you very much, students.